All right, adding and subtracting rational expressions. Well, since they're fractions, let's go back and take a look on how to add fractions. So let's say if we had like 5/4 plus, I don't know, 7/6. Well, anytime we add or subtract fractions, we need a common denominator. Now, least common denominator we do with numbers is generally we say, what's the smallest number that's divisible by a 4 and a 6? But there's an easier way to do it when it gets when we have variables and all kinds of craziness laying around. Let's go ahead and factor each one of these denominators. Now, here I'm writing each one of them in their prime factored form. To find the LCD, you always take each factor the most times it occurs in any denominator. All right, so what do I mean by this? If we look at the first denominator, there are two factors here, a 2 and a 2. And in this denominator, we have two factors also. We have a 2 and a 3. So if we take a look at all the factors, we have 2's and 3's, which means my least common denominator, I need 2's and 3's. Well, how many of each do we need? Let's take a look at the 2's. In this denominator, it happens twice. In this denominator, the 2 only happens once. So we need to take the most number of times it occurs, so it happens twice. We know we also need some 3's. 3's don't occur all over here, but occur once over there, so we only need 1 3. So this would be our least common denominator, which is 12. Once we have our least common denominator, once we know what it is, then we multiply the top and the bottom of each fraction by whatever it takes so that, well, it's the least common denominator. So let's move over here and say this again. Let's go back to 5/4 plus 7/6. Okay, so what would I have to multiply this by to make it a 12? Well, it would be a 3, so we'll multiply the top and the bottom by 3. We have to multiply this one by 2, so 2 over 2. So we have 15 twelfths plus 14 twelfths. Now these things are both 12, so we can add them together. Here I have 15, over there I have 14, so I have 29 twelfths. All right, now that we've finished adding together the fractions, we do try to reduce this. That fraction won't reduce, so that's it. Okay, so let's write ourselves down some steps right here and then see if we can do it when we have variables involved. So let's see, steps. Step 1, factor all the denominators. Step 2, find the LCD. Now, even though we have variables involved, we do the same thing. We take each factor the most times it occurs in any denominator. Then we multiply the top and bottom of each fraction by what its denominator is missing to be the LCD. 4, add the numerators and keep the denominator. And last thing you want to do, let's see if we can reduce these things. All right, so let's go back and try this with variables now. So let's see. Let's start out with something fairly straightforward. Let's say we have 4 over x minus 3 plus 5 over x plus 2. All right, here we're adding two fractions or rational expressions, so we know we're going to need a common denominator. To get a common denominator, we want to factor each one of these denominators. Well, they're already factored, so we need to find the LCD. Well, this one only has one factor, and you can think about it if you wanted to put those in parentheses. The only factor here is an x minus 3, and the only factor over here is an x plus 2. So my least common denominator is going to need x minus 3's and x plus 2's. Well, how many of these do we need? Well, an x minus 3 occurs once over here, no times over there, so it only occurs one time at the most. X plus 2 doesn't happen at all over here, happens once over there, so the most is 1. All right, so let's see. We're going to take each one of these fractions, x minus 3, 5 over x plus 2, and we're going to multiply the top and the bottom by what it's missing. This one already has the x minus 3, it's missing the x plus 2 to be the LCD, so we write plus 2 over x plus 2. This one's missing the x minus 3, so we multiply the top and the bottom by x minus 3. Now, since we have to distribute here, don't distribute yet. Wait one more step. That's going to keep some sign mistakes from happening. So here I got to do 4 times x plus 2 plus 5 times x minus 3. And notice we have the same denominator now. So here we have x plus 2, x minus 3. Okay, go ahead and distribute on the top and combine like terms. So we have 4x plus 8 plus 5x minus 15 all over x plus 2, x minus 3. Combine our like terms, so that's going to give me a 9x. 8 minus 15 would give me negative 7 all over x minus 3, x plus 2. All right, now that we can't combine any more like terms on the top, we are done adding these fractions. So now we want to see if we can reduce. Remember, to reduce rational expressions, we factor the top, factor the bottom, and see if anything will cancel. Well, the good news is the bottom's already factored for us. Well, the top won't factor anymore, so that's it. We're done. We are done adding those two rational expressions. All right, let's try another one here. Make it a little bit harder. So let's see. What if I gave you 4 over x squared minus 9 minus 7 over x squared plus 6x plus 9. All right, let's do this kind of in steps together here. Do the first 2 steps for me, please. Factor each one of these denominators and see if you can figure out what the least common denominator is. So hit pause and go do that. All right, so let's see, if you're back, you should have been able to factor these. The first one's just the difference of squares. That should factor to x plus 3, x minus 3, minus, the next one's the AC method, and we can use the shortcut x plus 3, x plus 3. So we should be able to figure out what our least common denominator is here. So in this denominator, we have 2 factors. We have an x plus 3 and an x minus 3. This denominator also has 2 factors, but they're both an x plus 3. So looking at all the factors, I know my least common denominator needs x plus 3's and x minus 3. So how many of each do I need? Well, x plus 3 happens once in this denominator, twice in this denominator. So the most times it occurs is twice, so I need 2 of them. X minus 3 shows up once in this denominator, 0 times in that denominator, so the most times it shows up is once. So this is our least common denominator. So now we're going to take each one of our fractions and multiply it by what it's missing. Its denominator is missing to be that least common denominator. So this one has an x plus 3 and an x minus 3. We're missing one other x plus 3, so I'm going to multiply the top and the bottom of that one by x plus 3. This one's missing the x minus 3, so I'm going to multiply the top and the bottom by x minus 3. Now here, since we have to distribute on the top, we're going to write one more step. So that's going to be 4 times x plus 3 minus 7 times x minus 3. And of course, we already have a common denominator. That denominator is x plus 3, x plus 3, x minus 3. And it doesn't matter what order those are in, of course. All right, so now what we got to do is go ahead and distribute everything out on the top and combine like terms. So let's move this up here. So that's going to give me 4x plus 12 minus 7x plus 21 all over x plus 3, x plus 3, x minus 3. Combining like terms, what are we going to end up with? That's negative 3x plus 33, x plus 3, x minus 3, or x plus 3, x minus 3. Again, it doesn't matter what order those show up in. All right, so since we're done combining like terms in the numerator, we are done adding these fractions. So the last thing we want to do is see if we can factor and reduce. On the top, we can factor that a little bit. There's a factor of 3 or a negative 3. I would probably take out a negative 3 there. And that would give me x minus 11 all over x plus 3, x minus 3, or x plus 3, x minus 3. All right, now since nothing will reduce here, either one of those would have been a correct answer. All right, adding and subtracting rational expressions. Factor all the denominators, figure out what the LCD is, multiply the top and the bottom of each fraction by whatever its denominator is missing to be the LCD. Combine like terms in the numerator, and then see if you can reduce the fraction. All right, that's it for adding and subtracting rational expressions.